Welcome to this presentation on PSCAD simulation of adaptive distance relay for microgrid with a type 4 wind turbine connected. The type 4 wind turbine generator model is available in PSCAD. So that model available in PSCAD you can directly add to the grid system. The type 4 wind turbine model of PSCAD contains important components such as pitch controller, wind turbine, the mechanical models, then electrical components such as the machine side converter, its controller, then grid side converter, its controller. So all these things are available in the type 4 wind turbine model of PSCAD. So students aspiring to do project related to wind turbine, they can use the model available in PSCAD version 5. So if you have older versions of PSCAD, this model may not be available. So if you want to develop the project in PSCAD, you need to add a single type 4 wind turbine model and then study its impact in the grid connected system. So you can create different faults and see what is the response of the wind turbine. And for the test system, I would select or I would suggest students to select a simple bus system. It can be a 3 bus system or a 5 bus system. First, the voltages and currents of the 5 bus system, that you need to check the waveforms whether they are all proper sine waves with the mentioned magnitude and frequency. So once the waveform is proper sine with good magnitude, then you can connect the type 4 wind turbine. And type 4 wind turbine in PSCAD, it is representing the permanent magnet synchronous generator, PMSG. And a little bit advanced stage of this design is to go for a Moven relay. And again, in designing the Moven relay, many students are having the opinion to calculate the value of impedance by manual calculation. So that is not a proper way. For a proper power system with n number of generators, manually calculating the value of Z, that is the Thevenin's impedance seen across or viewed at the point of fault, that cannot be calculated manually. The value of Z Thevenin, that is at the fault, cannot be calculated manually. So you need to do it in PSCAD, and by trial and error you can adjust the value of the value of Mo for proper operation of the Mo relay. And once you have designed the power system, you can work on different cases. One is with a V grid, then LG. I mean, you create LG fault. With the V grid system, you create double LG fault. Then you go for strong grids. Compared to the wind turbine, the grid is strong. So in that case, you simulate LG and double LG faults. Then you can also study what is the impact of power swings on the protective relay. Here it is the Mo relay or distance relay. How the power swing affects the Mo relay or distance relay, so that can also be studied. So in PSCAD, in the project, you need to develop these results: the voltages, currents, power flow at the point of common coupling, then reactive power, and for the various types of faults, you should create the Mo circle, and whenever the fault occurs, the circle should be intercepted. So that is the working of Mo circle. Students interested in buying this project, you can contact my WhatsApp number. And again, I don't provide or share projects on free basis. So our institute, it is a training institute where we train students on power system softwares, and we don't sell the software. So students interested in purchasing the PSCAD software, you should directly approach the PSCAD sales team, and from them you should purchase the software. For consultation or training or demo classes, we will do with the free version of PSCAD. Full version of PSCAD we don't sell, and students should possess their own full version of PSCAD before starting the project. So projects, if you need, you can make the fees as a freelancer. We will work on those projects, and we can meet your research requirements. I have given my WhatsApp number, so interested students can contact me on WhatsApp and get your research done.